Hey y'all. In the last video, we took a look at Solidity arrays and maps. We compared the two and we went through some basic examples. In this video, what we'd like to do is take a look at some of the global variables and functions that are available to us within Solidity development. Specifically, we want to look at the message object and the msg.sender and the msg.value. Now, what do I mean by global variables and functions? So basically, a global variable is something that's accessible to us in any place of our smart contract. We say that the information stored within these variables are globally scoped. It's information that we can access at any time to be able to read the values, which is super useful for certain aspects of smart contract development. Really, if we want to see who is calling into our smart contract or how much value has been sent into our smart contract, we could do that using these global variables and functions. So before we unpack some of the msg.value and msg.sender, I want to talk a little bit about the different ways in which we can call into smart contracts. And there are really two core ways that we can call into smart contracts. The first is simply called a call, and that is when we're calling into a method that just returns a value. So in our example contract here, we have this method called sayHello, and you can see that it's marked as a view function. And all it does is it returns this hello variable. It doesn't change anything. It just returns a value from one of the state variables inside of our contract. There are no state changes, only reading of a value. These types of calls are free. They do not cost any gas. So we can call right into them and get the value for no gas costs. Now, we wouldn't be sending any ether or any value in this situation because it's not a transaction. And that leads us to the second type of interaction of a smart contract, which is a transaction. And typically on the front end, we use a send call to be able to send a transaction. This is going to build a full transaction. It's going to sign that transaction, and then we publish it and broadcast it to the network. Transactions will, in some cases, change the state of, actually probably in most cases, change the state of our smart contract, either by adding value into the smart contract by sending ether or changing some of the state variables within that contract. And you can see that here with this add to whitelist method, which takes in a new member address and pushes the member into this whitelist array. That's changing state within this contract. In order for this to execute successfully, we do need to send some gas and a transaction up to the network in order for this to work. Now, because we're able to send value and send transactions to contracts, the properties of those transactions and all of the information surrounding that transaction is accessible to us within our contract. And this is where a good amount of these global variables and functions derive from, is that we want to be able, or we need to be able to kind of read our surroundings in order to see, hey, what is the context of which I'm executing this transaction? Is the user a certain address, or has the user sent a certain amount of value? I need to be able to test these things in order to execute and fulfill the needs of our contract. So we saw a little bit of this in our last lesson when we took a look at the msg.sender. So this add balance method, it basically adds a balance index or increments the balance for a given sender in this balances map. Now, this is a pretty simple example here, but it is using this msg.sender global variable. And what this is going to return is the immediate caller's address to our contract. Now, what do I mean by immediate caller? That means that the last piece of software, it could be either an externally owned account, which is just a regular user account, or it could be a smart contract that called into this contract. Because there could be some really complex interactions of smart contracts happening on the blockchain, right? So I could call into, say, a Uniswap contract that then calls into a bunch of other contracts in order to fulfill the swap that I'm trying to do. Now, in that case, when the Uniswap contract calls out to other contracts, the message sender property here would be the actual address of the Uniswap contract, the immediate caller to wherever that calls out to. So that's a really important distinction, because this msg.sender may not always just be an externally owned account. It may be an actual contract. So this is going to return basically an address, and we can use this address to store in this map, this balances map. Awesome. So that's kind of the first global property that we're looking at here within this messages object. What about value? How do we actually get some value into our contract? And now this is probably something you're going to want to do. You want to be able to take payments for, say, an NFT or some type of service that you're providing within your smart contract. So how would we do that? Let's go ahead and let's create another function here. I'm going to call it charge customer. And basically, we're not going to take any parameters to this. We'll make this public, and we're going to make this payable. So now by making this function payable, it expects to receive some value, right? So now this function can receive value. That means that we can send a transaction to this function, and we can test for certain values. So why don't we do this? Why don't we say, just to call this method, it's going to cost you 1 ETH. I hope this method does something really cool, because that's pretty expensive to be able to just call into this method. So let's go ahead and say, we're going to use the require function here, which is basically a way for us to put stop gaps, or just kind of gates within the execution cycle to say, hey, in order for you to get past this line of code, this conditional needs to be true. And what are we going to test here? Now, we know that the msg.sender is going to return the sender's address, but that's not really what we're looking for, right? We want to be able to test the value that was sent to this method. So instead of sender, we could say value. And we're going to make the value, we'll require it to be equal to, say, 1 Ether. Awesome. Now, this is actually a really interesting tidbit. There are some native units that we can use within Solidity that makes it pretty easy to work with these types of values, which is mega convenient. Instead of, putting the GUI value in here, right, and having a million zeros after this, we could just say 1 Ether. Awesome. Now, if it's not true, this would throw an error. So I'm going to go ahead and throw an error of please send 1 ETH to call this function. Awesome. So if whoever is calling this function, it could be a user account or it could be another smart contract, it requires them to send at least 1 ETH within their call to be able to execute this. Now, if 1 ETH was sent, then we could do something like, hey, maybe we'll take this balances array and we'll say, all right, cool, they really want to call this function, so let's give them a lot more in their balance here. So we're going to go ahead and increase their balance by 1,000 if this holds true. So you can see here that we're using the msg.value and the msg.sender in order to read information about who sent the transaction into this function. So that's really these two properties here are super valuable, because they're really what's going to enable us to grab value from a transaction and read who actually sent the transaction. So there are actually a bunch of other globally scoped objects and variables. I'm going to go ahead and leave a link within the show notes here to the Solidity docs. And there's a bunch right here, block and transaction properties. We have a block object as well, in which we can kind of read information about the blockchain's current state. So the base fee, the gas limits, we can even read a timestamp, which is mega useful. So if we wanted to say, hey, a timestamp needs to be greater than a certain time, we could go ahead and do that, right? So like say, for example, we were in here and we said, okay, we're going to require that the customer sends at least 1 ETH, but we only want this to also execute after a certain date. So we could say that require block.timestamp is greater than some value. Now this would be a Unix timestamp of the epoch date in UTC. So if you're not familiar with that, that's something that's pretty standard within time and in different programming environments. But the epoch time is the number of seconds since January 1st, 1970. And this is going to be in the UTC time zone. So this is going to return the number of seconds since 1970 in UTC. The beginning of the day in 1970, right? 0000. So we could go ahead and say if we had another Unix timestamp here, which I don't have one handy, I'll just put some random value in here. But say this is a certain date in the future that we're not at yet. We could say this sale has not started yet. And this is super useful because this information, assuming that when we publish these contracts to the actual networks, they are verified and visible within the block explorers that we use, we can go ahead and read these contracts and say, okay, this makes sense. The sale hasn't started yet. I could see exactly when the sale starts by reading this date. Of course, these values here can be added to state variables within the contract themselves. They can also then be exposed to change by, say, an administrator account through other methods. So we can use these global variables to really kind of read the environment around us and then make decisions and maybe even set constraints based on those values, as we could see here. Mega valuable stuff, right? So now in this case, if this was to execute properly and all of the conditions are met, now this contract would actually have a balance of 1 Ether after a single call to this customer. This is charge customer function. So that's a topic for another day, but that's a really important note because now 1 Ether will be sitting in this contract. Now, I'll leave you with this question. Will the Ether in this contract be accessible by us? Will we be able to actually extract the value out of this contract in its current state? Think about that for a second. We're going to take a look at that most likely in our next video. I think we may start to move away from the Remix IDE, and I might start to use some of our local tools, because then we can get into some of the testing routines, and then we can start to really look at deploying to different test nets and things like that. So we may switch gears in the next video, but think about that question. Is this Ether accessible if we were to send 1 ETH to this? Could we get it out of this? And I'm going to go ahead and link to in the show notes some of this documentation. There's a lot of really great stuff in here. Like we can use time units in a very clean way. So we can even add, we could do something like this. Is greater than timestamp plus 1 day or something like that, right? So right now plus 1 day, or we can manipulate time pretty easily using these native units here, which is super cool. In some other environments, it's a little bit more of a pain in the butt to do that, so that's kind of nice. So yeah. Hopefully you guys are enjoying this series. If you have any comments, suggestions, please post them below in the notes, in the comments below. And we're looking forward to making more of these. All right, thanks.